Welcome back. Now we address problems from web work. Section 6-8, indeterminate forms and L'Hopital's rule. Problem 1 has many subparts. Well, the point is to detect what is indeterminate, what is zero, and what is infinite of some kind or does not exist. Indeterminate is different from does not exist. All right. What is 1 times infinity? That is, you have a limit that's approaching 1 and then you're multiplying to infinity. So you pretend you are approaching 1. So you are 1 point something times infinity. That is huge. 0.98 something times infinity. That is huge. So 1 times infinity is actually approaching infinity. So it is does not exist. It's not a real number. That's what it means. Okay. Next, infinity to the power 0. You can imagine something is getting very large and its exponent is getting very small. Okay. So this is indeterminate. All right. Because power is getting smaller and smaller, but the base is getting larger and larger. So this is indeterminate. 0 to the power infinity. Well, imagine the base is getting smaller and smaller and you are taking larger and larger powers. 0.001 power 10. It's actually even smaller, okay? So this is approaching 0 actually. All right. 0 times infinity, that is indeterminate. I have written indefinite, that's incorrect. Indeterminate. Okay. 1 power negative infinity. So something is approaching 1 and then power is getting very large on the negative side. It has the same effect as 1 to the power positive infinity. It's indeterminate. Now, infinity to the power infinity. So, pretend your base is getting larger and larger and larger. And negative power, negative larger and larger. So, 1 over a large number. So, that's approaching actually 0. Base is approaching 1. Power is approaching 0. Okay. So, together they are approaching actually 1. Base is approaching 1. Power is approaching infinity. So that's indeterminate. Zero over infinity. That is 0. You see, numerator is very small, denominator is very large. So the fraction is simply going to be 0. 0 power negative infinity. That is, your base is approaching 0. And power is approaching a negative large, going larger and larger on the negative side. So it's a fraction approaching 0 in the bottom. So that is does not exist. Okay. Next. Pi to the power infinity. Well, that's getting infinite. Okay, so that does not exist. Next, infinity times infinity. That's a huge number. So larger and larger numbers, the product is getting large. Infinity to the power 1. Well, you're getting larger and larger and taking a power that's getting closer to 1. So it is a large number. Limit does not exist. That's indeterminate. Infinity over 0. Well, so the fraction is getting very large. Numerator is very large, denominator is very small. So the fraction is very large. So that is what it is to say does not exist. 0 to the power 0. So number base is getting very small. Power is also getting very small. We don't know where it's heading towards. Indeterminate. pi to the negative infinity, that's going towards 0. 1 over negative infinity, that's approaching 0. Infinity to the power infinity, that does not exist. It's a large number. Infinity to the power negative e, so it's approaching 0. Okay, I hope they're all correct. All of the answers are correct. Okay, next problem. You want to use L'Hopital's rule. Limit x approaching 0 sine 2x over tan 11x. If you remember, we had solved such problems in our earlier sections. Okay, so let's look at this. So you're looking at limit x approaching 0 sine 2x over tan 11x. So that's indeterminate of the form 0 over 0, because x approaching 0 sine 2x is 0, tan 11x is also 0. So 0 over 0, you can use L'Hopital's rule. Okay, take derivative of the top, cosine 2x, chain rule gives me another 2. Derivative of the bottom, derivative of tan is secant squared, and then chain rule gets me an 11. Now when x approaches 0, numerator cosine 0 is 1, secant squared 0 is also 1, so 2 over 11 is your answer. Good. Next problem. Evaluate limit using L'Hopital's rule if necessary. Limit x approaching 0, 14 power x minus 3 power x over x. X approaches 0, that gives me 1, that gives me 1, 1 minus 1 is 0. And this is 0. So this is limit indeterminate of the form 0 over 0, so you can apply L'Hopital's rule. When you apply, I hope you can see, when you apply L'Hopital's rule, derivative of the top, derivative of 14 to the x is 14 power x, natural log 14. Derivative of 3 to the x is 3 to the x, natural log 3. Derivative of denominator simply 1. Now when let x approaches 0, that should be 14 by the way. 14 power 0 is 1. 3 power 0 is 1. So they give me 1 each. Natural log 14 minus natural log 3. Okay, next problem. So I better fix this. That's a 14. All right. Next. L'Hopital's rule. Limit x approaching infinity, 5x cube over e raised to 9x. 5x cube over e raised to 9x. When x approaches infinity, this is an indeterminate form of infinity over infinity type. So apply L'Hopital's rule. What happens to the numerator? You take derivative, 15x squared, take the derivative, oh, I'm sorry. So this is e to the 9x, not 3. Good. Now, derivative of exponential, e to itself is itself, e to something is itself, chain rule fetches me a 9. When x approaches infinity, that goes to infinity, so does this. So L'Hopital's again. Derivative of the top 30x, derivative of the bottom, that 9 comes down again, 81 e to the 9x. Again I have limit x approaching infinity to be infinity over infinity. So take derivative once more, 30 upstairs, and get one more 9 going, so 729. Okay. Now when limit x approaches infinity, numerator is constant, but this denominator, because of that x, all of that goes to infinity. So you have the fraction to be 0. Okay. Next problem. Compute using L'Hopital's, if appropriate, 4 sine x, natural log x. X approaches 0 from the right. 4 sine x, natural log x. Okay, let's see what happens here. as x approaches 0, this goes to 0, this goes to negative infinity. So you're indeterminate of the form 0 times negative infinity. So first you need to rewrite. So take that sign and place its reciprocal below. Reciprocal of sine is cosecant. So now when x approaches 0 from the right, this goes to negative infinity. This goes to positive infinity. So you have infinity over infinity situation. So you can take L'Hopital's rule, take the derivative. Derivative of the top is 4, 1 over x. So there's that x. Derivative of cosecant is negative cosecant tan. That's all there. You see, now I have a sign in the denominator here and a sign in the denominator. So I brought them up. Whereas, so cosecant is 1 over sine. So one of the signs is here. Tan is cosine over sine. So that cosine is here and the sine denominator came up. And there is an x. Now you see, now this is very nice. You can actually notice sine squared x, I can write it as sine x, x cosine x cosine x. So you see this particular part, okay, whoops, why did it do that? This particular part is going to give me 1 when x approaches 0. Numerator, so that's a 1. Numerator is a 0. And denominator is only cosine is left. As x approaches 0, it's 1. So 1 times 0 over 1. So that's an actual 0 over here. Okay. Correct. So let's continue the rest of the problems in our next video. Until then, see you.